Alrighty, let's get started with video number 2 tonight, ladies and gentlemen, on graphing proportional relationships. This video should be significantly shorter than the rest. Ladies and gentlemen, we are going to compare some proportional relationships. And in our first example, our only example, but there's a couple parts to it, it says, at a track event, the distance y in meters traveled by student A in x seconds is represented by the equation y equals 7x. The graph shows the distance traveled by student B. Well, just reading that information, before we're even asked a question, let's take a look at this graph. And it does say student B up at the top. It says student B. So we can see that the y is the distance in meters, and that the x, where does it say here? The x is the seconds right here. X is seconds. So we can see that we have a distance per time. So anytime you're asked to find the slope of that line and interpret it, you know y goes over x, so distance goes over time. So you would interpret that slope as distance per time, or meters per second. Got it? All right. So then it says it's represent the student B, and so this line here represents student B. We know it's a proportional relationship for a couple reasons. One, it does pass through the origin. And two, we have a constant rate of change. It is a line. And just by looking at it, we could interpret, maybe if this is super accurate, that it's saying 8 meters per second if we go on that graph. But one, let's prove that it's proportional. Let's prove it's proportional. They gave us these 2 points, 324 and 648. So I'm going to set up a proportion with those two ratios. 24 meters in 3 seconds. Is that equal to 48 meters in 6 seconds? And we can see right away that they are, because I can multiply 3 times 2 to get 6, 24 times 2 to get 48. And if I simplify them, then we would have the slope. So 24 over 3, that is 8 over 1. So my slope, my constant of proportionality in this graph is 8 meters per second, right? 8 meters per second. Outstanding. So, hey, I have a question for you. We have talked about every single point on this line being a solution to the equation. And if we write the equation for this student B, because it's 8 over 1, we would have the direct variation equation, y equals 8x. All right, and so we're wondering, every single point on this line, is it a solution? In other words, if I ran for, say, 1.5 seconds, let me mark 1.5 seconds with red. If I ran for 1.5 seconds, would this be my distance? Is that a real point? Well, yes. So this is a continuous graph. All that data is good. Now, why don't we go less than 0, 0? Why don't we go negative? Yeah, that's right. We cannot run negative meters in negative time. That would not make sense in the real world. So now that we've kind of understand this graph a little bit, and we see that student A up here, it says student A is represented by the equation y equals 7x. So y equals 7x, that's another direct variation equation. And we know that the slope would be 7 over 1. It wants to know which student is faster. Well, we've kind of already solved that, because when we took a look at this graph, we wrote the direct variation equation for student B as y equals 8x. So the slope was 8 meters per second. And over here, for student A, y equals 7x. So that's 7 meters per second. So who's faster? That's right, student B. Student B is faster by 1 meter per second. Make sense? All right, let's move right along. So, ladies and gentlemen, continuing with this graph, it says, graph the equation that represents student A in the same coordinate plane as student B. Compare the steepness of the graphs. That's another definition of slope, right? Steepness. What does this mean in context of the problem? So we remember that student A was y equals 7x. So we can make our table of values, and we know that if they ran for 0 seconds, that they're going to go 0 meters. And if they run, well, let's just do the same points as they're on the graph for student B. What if we run 3 seconds? That means student A would run 21 meters. And if we ran for 6 seconds, that means student A would run 42 meters. So when we come over to the graph, we can graph student A with these red points, 0, 0, 3, 21. So we're going to guess 21 is approximately yo. And then we're going to go to 6 seconds and go to 42 meters and say that's approximately there. And then I'm going to do the best I can. You have a straight edge to graph with precision. And there's mine, not so good. But we can see that student A is not as steep. It doesn't go up as fast as student B does. So we've graphed that equation. We've graphed the distance that student A runs every second. And we've noticed that it's not as steep as student B. And so that means not going as fast. What does it mean? That student A is not going as fast as student B. So, ladies and gentlemen, I told you to be short. That's pretty much what it is. We are done. You do have a quick write. That quick write says, hey, at the concession stand, hamburgers are selling at a rate of 160 burgers per hour. And the table shows a rate at which wraps are selling. And so the question is, do hamburgers or wraps sell faster? And you need to explain. So you're going to be comparing this proportional data. Do not forget to write down questions that you have regarding, graphing proportional relationships. That's a bad mistake on my part. So graphing proportional relationships. Bring those to class. Okay, bring them to class. Make sure you talk about them and ask about them in class. Ladies and gentlemen, make sure your notes are completed with quality. Do you need to rewatch anything? Man, remember, attitude and effort are everything, and it's always, always an honor to be a part of your learning process. Ladies and gentlemen, I'll see you tomorrow.